Hi everyone, for today's lesson, we are going to learn how to apply the law of cosines. Our learning targets for today are for you to be able to say, I can use the law of cosines to solve any triangle when given side, angle, side, and side, side, side. For today's warm-up, I would like you to look at our given triangle where two side lengths are 80 feet and its included angle is 110 degrees. Please find the area of this triangle. I would like you to please pause the video, answer this question. You might need to refer back a couple of lessons in order for you to look at that area formula again. That's totally fine. But when you have an answer, please go ahead and restart the video and we will see how well you did. All right, so our area formula when we are given side, angle, side is the following. Area is equal to 1/2 times your side number 1 times side number 2 times the sine of your included angle. So this is the formula that I am working with. So that is sine of our included angle. So my area is equal to 1/2 times 80 times 80 times the sine of 110 degrees. And when you put that into your calculator, you find that the area is 3,007.2 or 0.02, feet squared. So hopefully you were able to get that answer correct, and finding area is not that bad for you. So in day 10, where this lesson actually, or this idea actually came from, we learned about the law of sines, and we used the law of sines to help us solve for triangles when we were given angle, angle, side, angle, side, angle, and then in day 11, we learned all about the SSA ambiguous case, but we used the law of sines for those problems. And what was nice about these particular pieces of information is that we were easily able to come up with two of a kind. So now what do you do when you don't have two of a kind and it's really challenging to come up with two of a kind? Well, mathematicians identified a thing called the law of cosines. And the law of cosines is what we use if we are given side, angle, side, or side, side, side cases. So the following formulas are for when you have side, angle, side. This is our triangle that is the same triangle that we've been working with. ABC and opposite of angles A, B, and C, we have little a, little b, and little c respectively. So our formula for the law of cosines is a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Or if you know b, or we want to try to find b, we have b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Or we have c squared is equal to a squared plus b squared minus 2ab times the cosine of c. So you might be looking at this saying, oh my goodness, that is a lot for me to learn. This is a lot of information, so I want to kind of break it down for you. Essentially, we're going to have the side that we don't know is equal to the square of the other two. So it kind of looks like the Pythagorean theorem, only these aren't right triangles, so it's not going to be exactly c squared equals a squared plus b squared, but that first part definitely looks like the Pythagorean theorem. So if we can kind of think about it like that, it might be helpful. Then we have obviously minus 2bc. So whatever letters you're using here, minus 2bc, minus 2ac, minus 2ab. Those letters are going to be used again. Those side links are going to be used again. And now what angle you're taking the cosine of? Well, if you start with a side A, it ends with angle A. Side B ends with angle B. Side C ends with angle C. So in words, essentially, if you have side, angle, side, this is your unknown side squared is equal to your other side, whatever other side that is, squared, plus the last side, we'll call it side 2, squared, minus 2 times the length of side 1 times the length of the other side, we'll call it side sub 2, times the cosine of your included angle. So this is side angle side. So if you think about it, it's going to be like your included angle because you're going to know a side, your angle, and then another side. So we're going to call that the included angle. So once again, if you need to see like a picture of what side angle side looks like, so this is side angle and then side. So that's the information that you will see. This angle right here is referred to as, I'll call this side 1, we'll call this side 2, and this is called an included angle. And so that'll be the information that you will have, and we're going to use the law of cosines to help us to find our missing angle. So make sure you leave a little bit of space because we're going to talk about how to find missing side lengths in just a moment, how to find missing angles in just a moment, but we're going to hop into example number 1. And in example number 1, this is a problem where you are given, let it clear up for a little bit. This is a problem where you are given side, angle, side. So notice I have a side, an angle, and then another side. And what we want to do is we want to solve this triangle. And so if we're solving this triangle, that means that we need to identify all of our pieces. So we need to identify angle A, angle B, angle C, little a, little b, and little c. So step number 1 is we use the law of cosines to find our missing side length. So that's what we do first. We use the law of cosines to find our missing side length. So I'm going to find little b first, since I know all of the other ones. So I know that we'll call side A is 7. Side C, I know, is 12. I don't know what side B is. I do know that angle B is 26 degrees, but notice I don't have 2 of a kind. I can't like easily use Pythagorean theorem to come up with that either. So we just have to be really careful. So I'm going to write b squared is equal to a squared, well, so that's going to be 7 squared, plus 12 squared, so those are my other 2 sides, minus 2 times 7 times 12 times the cosine of 26. Now, what's really cool about this is that 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of 26 degrees, making sure your calculator is in degree mode, that's all a number. And we can put that into our calculator exactly as we see that. I'm going to make sure my calculator is in degree mode, which it is, and I'm going to go 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of 26. So I put this into my calculator exactly as I see it, and I end up with b squared is equal to 42.0026. And I like to do 4 decimal places. You could also just do like second square root if you wanted to in your calculator, but we're going to take the square root now of both sides, and I'm not going to use a plus or minus because we're talking about length, but I'm going to go second square root, or second x squared to get square root, 42.0026, and I end up with 6.48. So we're just going to round our answer to the nearest hundredth. So b is equal to 6.48. So now I have all of my side lengths found, and now I need to talk about angle measures. So now that I know that b is equal to 6.48, this is where we have choice. It says when you know all 3 sides like we do now, and 1 angle, you have 2 choices. you can continue using the law of sines again, which means if you choose the law of sines, you have to find the largest angle next. And the reason why you have to find the largest angle next is because the law of cosines produces obtuse angles. So if there is an obtuse angle, then we would be able to find it using the law of cosines. And that's because if you remember, cosines is whenever a calculator is giving us an answer, it's giving us an answer between quadrant 1 and quadrant 2 from 0 degrees all the way to 180 degrees, which it means that an obtuse angle could be produced. But law of sines doesn't produce obtuse angles. Instead, the law of sines, if you do that, you do have two of a kind at this point, but you have to find the smallest angle next. And that's because if you think about sines, the sine function will only produce angles between negative 90 degrees and positive 90 degrees, which are acute angles only. So our smallest angle will obviously be an acute angle. So a lot of students like to go with the law of sines next, but it's totally up to you. I'm going to go with the law of sines because I now have two of a kind. And if I want to find what angle A is, I would simply do 7 divided by the sine of angle A is equal to, and I'm using side A because it's the smallest. So between 7 and 12, I know that 7 is smaller, so angle A has to be the smallest angle. So 7 divided by the sine of angle A equals my two of a kind, 6.48 divided by the sine of 26. And I'm going to do cross product. So I have the sine, or 6.48 times the sine of angle A is equal to 7 times the sine of 26. I'm going to divide both sides by 6.48. And I end up with the sine of angle A is equal to 7 times the sine of 26 divided by 6.48. I'm now going to take the sine inverse of both sides. And when I do that, the sine inverse and sine are going to cancel away, leaving me with A is equal to whatever this number is. So I'm going to put sine inverse of 7 times the sine of 24 divided by 6.48 into my calculator. And when I do that, I end up with 26.06. So that's about 26.06 degrees. So this angle right here is about 26.06 degrees. And now we have to find angle C. And to find angle C, we're using the 180 degree rule. So I'm going to go C is equal to 180 minus 26 minus 26.06. Well, you know what? Now that I'm looking at it, that's a sine of 26, and I just realized I did that. Hold on. Sine inverse of 7 times the sine of 26, there we go, divided by 6.48. And that is 28 degrees. Sorry about that. That's 28.26. This is 28.26. There we go. So 180 minus 28.26. There we go. And therefore, we find that C is equal to 100. So if I go to my calculator, 180 minus 26 minus 28.26, that is 125.74 degrees. And that is our first triangle that we have solved. And here is our answer. So this is when we are given side, angle, side. These are our steps that we're going to use. But let's say that we are given side, side, side. If you are given side, 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 that means you do not know any angles. If we were to draw a picture of what side, side, side would look like, we would know our 3 different side lengths. We wouldn't know anything else. So that would mean we would need to solve for an angle. So what I'm going to do is I'm going to actually take out or look at our first equation, and I'm going to solve for angle A. So I'm going to write a squared equals b squared plus c squared minus 2bc times the cosine of angle A. And I want to get the cosine of angle A alone. So what I'm going to do is I'm going to do like a switcheroo, and I'm going to subtract a squared on both sides. And I'm going to add 2bc times the cosine of angle A on both sides. And what that's going to do is it's going to eliminate the a squareds, leaving me with 2bc times the cosine of angle A equals b squared plus c squared minus a squared. Are you with me? I know that was kind of weird. So I subtracted a squared on both sides, and I added 2bc times the cosine of angle A on both sides. From here, I need to get the cosine of angle A isolated. So I'm going to divide both sides by 2bc. So the 2's cancel, the b's cancel, the c's cancel. And now I'm left with the cosine of angle A equals b squared plus c squared minus a squared all over 2bc. And now I'm going to take the cosine inverse of both sides so that I find that the measure of angle A is equal to the cosine inverse of this fraction, b squared plus c squared minus a squared divided by 2bc. This is a formula that I want you to know, and we would do the exact same steps every single time. So if we want to find a missing angle using the law of cosines, this would be our formula. In words, the measure of an unknown angle would be equal to the cosine inverse of side 1 squared plus side sub 2 squared minus your opposite side. So there's always going to be an opposite side of the angle that you want to find, minus your opposite side squared, divided by 2 times your side 1 times your side 2. And that is our formula for finding an unknown angle using the law of cosines. So one is just working with letters, the other one is just kind of explaining it in words. All right, let's go on to our next page where we are going to be finding or solving a triangle given side, side, side. Here we go. So in example number 2, once again, we want to solve our triangle. And this time I am given 3 different sides. So this is an example of side, side, side. So just like before, we are going to be working with the law of cosines. But because this is the law of cosines, we need to find the angle that is opposite of the longest side first. This is going to be our largest angle. So we're going to find our largest angle first. And that is to verify that we are not dealing with an obtuse angle, or if we are, we will obtain it because cosine inverse will produce obtuse angles if they exist. Law of sines will not. Here we go. So I can clearly see that 13, which is right across from angle B, is our biggest side. And so therefore angle B is my biggest angle. So I am actually going to find angle B first. And then obviously this is 7 is going to be A and 9 will be C. So I want to find my biggest angle first. So that means that I'm going to find angle B, which I need to establish. Angle A, angle B, angle C. I don't know any of my angles, but I do know little a is 7, little b is 13, and little c is 9. So we're solving this. Angle B is going to be equal to the cosine inverse of my other side. So my other sides are A and C. So that's going to be 7 squared plus 9 squared minus my opposite side, which is 13 squared, divided by 2 times 7 times 9. Now, could you put this all into your calculator exactly as you see it? Yes. But I have a lot of students who do that who end up getting the incorrect answer because we are dealing with fractions. So I like to come up with each individual numerator and denominator and then take the cosine inverse of it. So I'm going to put into my calculator 7 squared plus 9 squared minus 13 squared. So that's 49 plus 81 minus 169. And my numerator is equal to negative 39. My denominator is 2 times 7 times 9. So that is 14 times 9, which is 126. Notice we're going to be taking the cosine inverse of a negative number, which means that this is going to come from quadrant number 2, and we should end up with an obtuse angle. So I'm going to put into my calculator once again the cosine inverse of negative 39 divided by 126. And I end up with 108.03. And that is my first angle that I found, 108.03. At this step, so now that I know one of my angles, you have a choice. You can either use the law of sines or you can use the law of cosines to find your missing angles. Now, we always follow this order to make sure that the other two angles are indeed acute. This way, when you use the law of sines or the law of cosines to find another angle measure, you will know it is between 0 and 90 degrees. So you have choice. You can either work with the law of cosines or you can work with the law of sines. I think I'm going to work with the law of cosines just so I can show you that once again, and I think I'm going to find the measure of angle C. So I'm going to say angle C is equal to the cosine inverse of my other side. So that's going to be 7 squared plus 13 squared minus my opposite side of C is 9. So minus 9 squared divided by 2 times 7 times 13. I'm going to put this into my calculator and my numerator is 137. My denominator is 182, and I'm going to take the cosine inverse of that, which it's a positive answer, so that means it's going to come from quadrant number 1, meaning I will end up with an acute answer, and that answer is 41.17 degrees. 41.17 degrees. So I found angle C, so that's 41.17 degrees, and now I have to get to use the 180-degree rule to find the measure of angle A. So angle A is going to be equal to 180 minus 108.03 minus 41.17. So I'm going to put all of that into my calculator. And I end up with 30.8. So angle A is equal to 30.8 degrees, and there's my answer. And I've officially solved my triangle. If you have any questions over this lesson, please feel free to email me. We will do the team next time I see you. Feel free to try it on your own. Otherwise, I hope you have an amazing day.